Hello everyone. Today we are going to be talking about tape diagrams again. Tape diagrams and algebraic solutions. Algebraic solutions, an algebraic term usually has a variable in it, but not necessarily. But when we talk about algebra, we usually think of variables. Tape diagrams we have used in the past, the very first module, so today we're going to see how they relate. Before, I'd like you to pause the video and take a moment to use the distributive property to simplify, because our overall learning target, even though we're talking tape diagrams, is using the distributive property to solve problems. So please pause and see if you remember the distributive property, working forwards and backwards. Again, I hope you're really using this the way I mean it, and where you're actually pausing and being engaged and not just watching the video. You should be taking notes. Can't learn if you don't do. Alright, so the distributive property, remember, tells us that if we have a sum or a difference, we can multiply over the parentheses. And what we talked about, to help you remember, is the one outside of the parentheses is the player, and he wants to first go sit by one girl and then by another girl. Can't leave anybody out, so don't forget to go to that second number. So 30, 3 times 10 is 30, plus 3 times 8 is 24, so that's 54. Doing it this way is much more efficient than using the order of operations. Order of operations, we would have had 18 times 3, and we would have had more work to do, more thinking to do. So this one, a little bit simpler without a lot of thinking, a lot of arithmetic. All right, for this one, we're going to go backwards. So we could do 5 times 25 and then plus 5 times 75 using order of operations. But I see that I have a 5 in common, so I can pull out that 5 to make it 25 plus 75. So we took out that common factor of 5. So now I have 5 times 100, which is 500. So sometimes it's easier to use order of operations, and sometimes it's easier to use the distributive property. Here, by factoring out that 5, we could still use order of operations to go from there. Alright, this looks like a lot of writing, but this sets up 3 of our problems and notes and a couple of your problems in your assignment. So there's this family. John and Egg are the parents, and their children are Louie, Missy, and Bonnie. So there's 5 people in their family, so that's kind of important to this. And they're looking at their vacation expenses, and they wanted to figure out exactly what was going on. So we have different scenarios, and we're going to look at the algebraic way to solve and the tape diagram model as a way to solve. So pause, take a moment, read through this. Okay, so hopefully you had a chance to read through. The important information is that the entire family wanted to go. So now we know that we're talking about 5 different people. We know that it was raining, and so they're going to 2 different movies. The price of the matinee in the morning is different than the drive-in in the evening. And this is where I start writing down information, because I want to know what I'm looking for. I call it defining the variable. So first we know that the morning matinee, so the morning movie, is $6. And what I'm looking for, so that was right here. So each ticket costs $6. What we're looking for is how much did each person spend on movie tickets if the cost was the same for each. And before we can do that, we need to figure out how much the cost for the drive-in movie is. We know the morning movie, but the drive-in or the evening movie is what we're missing. So that is our unknown. Drive-in is going to be our X. Okay? So what does that look like algebraically? We know that we have 5 people in the family, and each one spent $6 in the morning plus X number of dollars in the evening. We don't know how much that is. So 5 people spent 6 plus an unknown amount. So right now that's the expression for how much each person spent, so right here, each person spent that amount. Now, what does this look like in a tape diagram? Well, oh, and we also know that they spent, if we go up here, they spent $75 total. $75 total. Okay, so our model, if we use a tape diagram, remember, it's like you have a piece of tape, and you have to break it into the number of rectangles that you need. Since there are 5 people in the family, we need to split it into fifths. And each person spent 6 plus x. And all together they spent 75. So all I'm doing is putting a visual. So we have each member of the family, and if you want, you can even write each of their names underneath. I'm not going to, but we do know that they spent 6 plus x. Oops, 6 plus x. 6 plus x. 6 plus x. So now we can see that they spent, if each one of them spent $6 in the morning, 6 times 5 is 30. So of this 75, 30 of it was spent in the morning. So now we're left with 45 that they spent in the evening. So we know if we took these 6's away, now we're left with 5. So now we have 5x that has to equal 45. And hopefully you remember, if it's multiplied, we divide. Or the other way you could think about that, and I want to start using this right away too, to get rid of a coefficient, you have to multiply by its multiplicative inverse. So it's really the same thing as dividing, but remember, dividing with fractions is multiplying by the reciprocal or the multiplicative inverse. So now that cancels out. 1/5 of 45 is 9. So what this tells me is that each evening ticket must be $9. So that's how you use the model. Now let's use the algebraic way. We know that in total they spent $75. So we could do this problem a few different ways, at least 2. We can use the distributive property to simplify. Remember, order of operations, when you're solving an equation, you have to work backwards. So we want to simplify this first. So 5 times 6 is 30. 5 times x is 5x equals 75. Now when you're solving equations, what you're really trying to do is get rid of everything except the x on a side. So you have to make, you're looking for zeros and ones. We want to zero this out. So what do you have to do to 30 to get down to 0? You would have to subtract 30. And if you subtract 30 on one side, you have to do it on the other. That's called the principle of equality. So now that's left with 0, and I have 5x equals 45. And here I want to get rid of that coefficient of 5, so it's multiplied, so I can divide, or dividing is the same thing as multiplying by the multiplicative inverse. That's called the multiplicative inverse property. This up here was the additive property, additive inverse property. So now I have x equals 9. So you can see, regardless of which way we used, the model or the algebraic way, we still came up with $9. And remember, we're doing a good model, so you have to say $9 per ticket. And we have to remember what the other question was. How much did each family member spend on tickets? Well, we have to go back to this. Each family member spent $6 in the morning and $9, so $15 total for each family member. The other way we could have done this, I'm afraid if I don't talk faster, we're going to have one of those lengthy ones. The other way we could have done this is way up here. We could have multiplied by the multiplicative inverse to get rid of that 5 first, to have left with 6 plus x on this side and 15 on this side, and then we could have subtracted 6. Alright, this problem very, very similar. The cost of, the family, so all 5 of them went out to a pizza parlor. The cost of a soda was $3. If each member had a soda and 1 slice of pizza, how much did the slice of pizza cost? So we can't figure it out with just this. We have to go up here and find how much they spent on soda and pizza. They spent $37.95 total. So I want you to pause, since this one is so much like the other one. See if you can do this. See if you can do the algebraic and the model to figure out how much a slice of pizza cost. Alright, let's see how you did. So I pulled out the important information. The total bill was $37.95. The cost of a soda was $3. The cost of our pizza was the unknown. So for 5 people, each person paid $3 plus whatever the pizza was, for a total of $37.95. So this was what it looks like algebraically. This is what it looks like with the model. So each person, and again you could even name John, Ag, Bonnie, Louie, Missy. So we could even name them, who had what, and then we can see that each person paid $3 for the soda, so 5 times 3 is 15. So of this $37.95, 15 of it was for soda. So the way we dealt with this over here is we did the distributive property to break through those parentheses. So there was 5 slices of pizza and $15 worth of soda, and then we use the additive inverse to get to 0. So 15 minus 15 gets us to 0, and if we subtract 15 on one side, we have to subtract it on the other. That leaves us with 5x equals $22.95, or 5 slices of pizza. 5 slices of pizza equal $22.95. Now I did the same thing except wrote it differently. So if it's multiplied, we divide, but if we're dividing, we're really multiplying by that multiplicative inverse, because we want to get to 1. Remember, if you multiply the multiplicative inverses, they get us to 1. So I did that on both sides to get $4.59. So here we have 5, and instead of showing it that way, I showed it like I was really just dividing. So 5x divided by 5, we still get our $4.59. Here I wrote it one last way. Instead of using the distributive property, I multiplied by the multiplicative inverse right away. I multiplied right away to get rid of this 5, so I was left with x plus 3. And then I had to use the additive inverse property. So to get to 0, additive inverse property, it was added, so I subtracted to get my $4.59. And then please remember that you need to do, it's a model, so you can't just leave it like this. You have to say each slice of pizza cost $4.59. Alright, I skipped the third example just because I know this video is already getting long, so if you do that and you want to make sure you did it right, please come and talk to me and I can help you through it. Alright, so this is one last one. I want you to read and try to pull out that important information before we get started. Alright, so we know $10 for the first hour. H, what we're looking for is how many extra hours were there. So H is the additional hours at 12 each. and Aaron made $58 total. So I'm going to start with my tape diagram, except this time I don't really know how many blocks I need. I know that for the first hour he made $10, and that for each additional hour he made $12, but we don't know how many hours there were. Sorry, these should be hours that look about the same size. So we don't know how many hours. So what that looks like algebraically is we know he started with $10 and then he added to that $12 for every extra hour for a total of 58. For a total of 58. So you could solve this problem just by guessing and checking. If we just had 10 plus the 3 extra hours that I've already shown, 3 times 12 is 36. So 10 plus 36 is 46. That is not enough. We needed to get to 58. So it's not enough. We needed 58. So if we added on another 12, now we have 46 plus another 12. That is 58. So now I can see on my diagram there is 1 extra hour, 2, 3, 4 extra hours, but we want to know how many hours total. So he babysat 5 hours total. Now what that would look like over here algebraically, we're just using properties, the inverse properties, to get h by itself. So something is added, so we have to use the additive inverse property first. It's added, so we have to subtract to get down to that 0. If you do it on one side, you have to do it on the other to keep the sides equal. So that cancels out. We're left with 12h equals 48. It's multiplied, so we have to divide, or we have to use the multiplicative inverse. So you can write it either way. The reason I'm emphasizing the multiplicative inverse is I know coming up we're going to have to use fractions. And so I like using that multiplicative inverse. So you could have shown it like that, or you could have shown it like this. But eventually you're going to have to use the multiplicative inverse. Either way, 48 times 1/12, 1/12 of 48, or 48 divided by 12, is 4. But remember, that just gives us the additional hours. So we need to add on that first hour. So he babysat 5 hours total. Didn't matter which way we did the problem, algebraic or with the model. Okay, sorry this is so long. We out.